Okay, what we saw in the video is that we can represent the parabola y equals ax squared plus bx plus c, which is known as the standard form. We can represent it using the equation y equals a times x minus h squared plus k. This is known as vertex form, where where hk is the turning point. Okay, and we then technically can say that x equals h is the axis of symmetry. Can you see me over there? Yeah, the axis of symmetry. So if you take any parabola, for example, y equals x squared plus 8x plus 2, you can either do it on the GDC, find the minimum point, and then take the turning point and put it in the equation, remembering that if h is positive, it's minus that value, and if h is negative, it's plus that value. Let's take an example here. So I know that my a is 1, my b is 8, my c is 2. My axis of symmetry has the equation of x equals negative 8 over 2 times 1, which is negative 4. I found the y by plugging the negative 4 back in the original equation. Negative 4 squared plus 8 times negative 4 plus 2. 32 minus 16 is negative 16, negative 14. And therefore, the equation allows me to write it as y equals x plus 4 squared minus 14. You can check in your graphing calculator, or Desmos if you don't have a graphing calculator, that these two equations represent the same parabola. Let's try another example. How about y equals x squared minus 10x plus 5. Okay, so once again, first of all, find the axis of symmetry. Well, first of all, find your coefficients. My a is 1, my b is negative 10, and my c is 5. Find your axis of symmetry. Once again, either you can do this in the calculator or you can do this by hand. Oops, sorry. We know that the axis of symmetry, x equals negative 10 over 2 times 1, which is 5. Coincidence. Find the y value of the turning point. Y is equal to 5 squared minus 10 times 5 equals plus 5. And so we get negative 50 minus 25 is negative 25, plus 5 is negative 20, and therefore we can rewrite the equation in standard form in vertex form as y equals x minus 5. Remember, if the x is positive, then it's minus that value, squared minus 20. Let's try one with a 2 in front, just to make this clear. How about y equals 3x squared minus 12x plus 5. It may look a little confusing, but once again, all we need to do is to write it in vertex form is to find the turning point. And to find the turning point. Let's find the axis. First of all, let's identify our coefficients. A equals 3, b equals negative 12, and c equals 5. The axis of symmetry is x equals negative 12 over 2 times 3. Now 12 divided by 6 is 2. And now we can find the y value of the turning point. Y equals 3 times 2 squared minus 12 times 2 plus 5. If you have a calculator, plug it in exactly. Remember, put the parentheses around the 2. If you're not using a calculator, well, let's think about this. Order of operations, 2 squared is 4, times 3 is 12, minus 24 plus 5. Negative 12 plus 5, negative 7. Now let's write this from standard form into vertex form. Remember vertex form. Can you see it over here? There you go. Remember, it's the A in front of here, right? So let's get back. Final answer: y equals 3 open parentheses your basic h and your k, x minus 2 squared minus 7, and that's how we go from standard form to vertex form. Either you're using the GDC or you're doing it by hand. Now let me show you an advanced technique. You will not be asked this, but it's called completing the square. Let's see if I can get it. Perfect. Here we go. This method is called completing the square, and once you follow these steps, you can quickly write it in vertex form. Now, you can do this with quadratic equations, or you can do it with parabolas. So if you do it with quadratic equations, it just makes your life easier to solve for x. And if you do it with a parabola, it's easier to find the vertex. So let's take our examples, actually. Let's start with y equals x squared plus 8x plus 2. So once again, this is advanced. Write your own rules down. Step 1, I'm going to rewrite this so that my 2 is away from my x squared and my 8x. Step 2, take the 8, divide it by 2, and square it. Well, 8 divided by 2 is 4, squared is 16. Well, I would love to have a 16 here because, I'll show you in a second, but I have to maintain the balance. So if I add a 16, I better subtract the 16. Okay, now for those of you, step 3. For those of you who've been practicing factoring your quadratics, you've gone through the factor madness, you've gone through this, we recognize that this is a perfect square. X plus 4 squared minus 14. If you recall from before, the turning point was, in fact, negative 4, negative 14. Let's try another problem. Y equals x squared minus 10x plus 5. So the first step was move that 5 a little bit over. Y equals x squared minus 10x plus 5. Step 2, take the negative 10, divide that by 2, and square it. Negative 10 divided by 2 is 5, squared is 25. So I need a 25 here, but I have to maintain the balance. If I add a 25, I better subtract the 25. Okay, last step. Well, if you notice here, because you've been practicing factoring trinomials, you immediately recognize this as x minus 5 squared minus 20. And then you say, oh, you know what, Mr. Allen, that was the answer we got over here. The turning point is 5, negative 20. Nice. Let's look at the last example. The last example we got over. Do we have room on the board? Yeah. The last example was y equals 3x squared minus 12x plus 5. What should we do? What do you think? Well, I'm going to... I like the step. My suggestion to you is, once again, it's an advanced thing. First of all, I divide out that 3, but don't cancel it. So divide everything by 3. We'll see what I'm going to do in a second. So I have y over 3 is equal to x squared minus 4x. Put that 5 over 3 all the way to the end. We'll take care of it at the end. So I have x squared minus 4. You say, oh, you know what? I can complete the square. Take the negative 4, divide by 2, and square it. Well, it takes us back to 4. Negative 4 divided by 2 is 2. Squared is 4. If I add a 4, I better subtract a 4. I have to maintain the balance, so adding by 0 really doesn't affect the equation. If you've been practicing your factoring madness, you know that this is x minus 2 squared minus Well, there's fractions there, but you know what? 4 is actually 12 divided by 3. Let's rewrite that. So it turns out that I actually have negative 7 over 3. And this was y over 3 equals this. So that looks weird. That doesn't look like the answer we had in the last problem. But you say, oh, wait a minute. The equation was in the form of y equals. How do we undo division? Well, just multiply. So if we multiply everything by 3, we end up with y equals 3 times this thing minus 7. And when we see the turning point is 2, negative 7. Another way we could use, once again, this is really advanced. I wouldn't even teach this to my 10s, my SLs, maybe my HL, but watch. Another way is y equals 3, open parentheses, x squared minus 4x, leave a big bracket over here, and put the 5 on the outside. Once again, I factored out a 3 here. Well, I have my x squared minus 4x. I know negative 4 divided by 2 is negative 2. Squared is positive 4. Add a 4, subtract a 4. Well, I have y equals 3 times x squared minus 4x plus 4 minus 12 plus 5. I'll leave it to you to figure out, where did that negative 12 come from? Final step, y equals 3, x minus 2 squared, minus 7. Just little tricks, just little things to pay attention to if you're going to use this method. It's not a coincidence that this ends up here. It's not a coincidence that negative 5 ends up here. And it's not a coincidence that the negative 2 ends up here. It's a way to help you. Good.